Okay, this is chapter 5.4, Equilateral and Isosceles Triangles. The essential question for this chapter section is, what conjectures can you make about the side lengths and angle measures of an isosceles triangle? What you will learn in this chapter section is how to use the base angles theorem and use isosceles and equilateral triangles. So let's take a look at what they're talking about. Okay, so using the base angles theorem, a triangle is isosceles when it has at least two congruent sides. A review from 5.3. When an isosceles triangle has exactly two congruent sides. So over here, they're talking about, let me get my highlighter. Okay, they're talking about this leg here and this leg here. Okay, when an isosceles triangle has exactly two congruent sides, this side's congruent to this side. They're called legs. The angles formed by the legs is the vertex angle. This up here, vertex angle. This leg and this leg form that angle. That is the vertex angle. The third side is the base of the isosceles triangle. So the side that is not a leg is the base. The two angles adjacent to the base are called base angles. Okay, adjacent means next to. Those are the two base angles. Okay, so now the theorem says, base angles theorem says that if two sides of a triangle are congruent, this is congruent to that, then the angles opposite them are congruent. So let me talk about opposite. Some students struggle with that term. So if this is side AB, there are three letters in the name triangle, ABC. Okay, ABC, there's three vertices, A, B, and C. There are three sides, side AB, side AC, and side BC. So if two sides of a triangle are congruent, then the angles opposite them are congruent. So if I have a side AB, this angle opposite is the other letter. So I've already said AB in the name of our side. So therefore the angle opposite is C, and it's over here. It's the one that is straight across from the side. Okay, so if AB is congruent to AC, the other congruent side is AC. Again, if I have the name triangle ABC and I name a side AC, the only letter I haven't used it yet is B, and that is the other angle. So what this theorem says is, if you have an isosceles triangle, the two sides that are congruent force the opposite angles to be congruent. So in this case, angle B is congruent to angle C. In other words, the base angles are congruent. Converse of the base angles theorem would be if two angles of a triangle are congruent, like B is congruent to C here, then the sides opposite must be congruent as well. So the side opposite C is the two other letters, AB. So side AB is congruent to side AC. Okay, and that's what they're talking about. That's the converse, going in the opposite direction. Okay, so now let's take a look at some problems that deal with that. Okay, so in this first example, it's just starting with the basics, not asking you to do too much here. It says in the triangle DEF, we have a triangle, DE is congruent to DF. That's our given. The markers are here and here. So there are the two sides of this isosceles triangle. So it's saying, since I have two sides that are congruent, name two congruent angles. So again, if you just look at the name, DEF, here's side DE. The opposite angle to DE is the other letter, F. So that's this angle. It's opposite this side. So you just draw an arrow over like so. That's the opposite side. The other side is DF. So here's D, here's F. The letter we didn't say is E. That has to be the angle opposite DF, which is E. So then I would say, it says name two congruent angles. I'd say angle E is congruent to angle F. And that's it. That's all he asked us to do. So with that example right there, you should be able to do problems 3, 4, and 6. Okay, so then we're going to take a little break from examples, and here's a corollary. 5.2, corollary of the base angles theorem. If a triangle is an equilateral, then it is equiangular. So in other words, here's side AB, here's side AC. Since the sides are congruent, that forces the opposite angles to be congruent. Okay, but look here, we have a third side congruent. Well, if I chose AC and BC, then these here would be my base angles. If I chose AB and AC, these would be my base angles. And then we could use the transitive property. There is a proof for this. I'm not going to go over it. So in other words, if two sides are congruent, the opposite angles are congruent. But if all three sides are congruent, then all three opposite sides are congruent as well. All right. And the corollary to the converse, if a triangle is an equiangular, then it is equilateral. Okay. So in other words, if we're told the three sides are congruent, then we know the three angles are also congruent. If we're told the three angles are congruent, then we can conclude that the three sides are also congruent. And that's about it for this corollary. All right, here's example 2. It says find the measure of all three angles. Okay, so here's what we're going to do. We have an equilateral triangle. Okay, all three sides are marked congruent. We can conclude from that all three angles are congruent. So equilateral triangles are equiangular. So I'm going to say the measure of angle P plus the measure of angle Q plus the measure of angle R equals 180 degrees. Okay, that's a triangle sum theorem. All triangles angles add up to 180. Now I know that these three sides are congruent, therefore the opposite angles are all congruent, and therefore they're all congruent. I don't know what they are, so I can just call them X. Since they're all equal, I can call them the same thing, and we're going to call them X. So I have X plus X plus X equals 180 degrees because all these angles have a measure that we don't know that are the same. Then I can combine like terms. X plus X is 3X. And 3X equals 180 degrees. And to find one of those X's, all we need to do now is divide by 3. And 3 divided by 3 is 1, or 1X. And so therefore X equals 18 divided by 3 is 6, and bring down that 0. So every angle is 60 degrees. So after I find this, I can say the measure of angle P equals 60 degrees. The measure of angle, forgot the angle symbol, the measure of angle Q is 60 degrees, and the measure of angle R is 60 degrees. Okay, so here's example 3. It says to find the values of X and Y in this diagram. The first thing I'm going to focus on, let me get my highlighter, is this triangle right here. So if I focus on this triangle right here, I see that all three angles are congruent. That's an equiangular triangle. Since it's equiangular, it's equilateral, and all three sides are congruent. KL is 4. So I could say, since that's an equilateral triangle, I can say, not the measure, that is a side. The length of KL is equal to the length of KN because all sides are congruent in an equilateral triangle. And since KL is 4, then KN is Y. Well, we just found Y. Y must be 4 as well. So Y equals 4. That part was easy. The next thing is finding the measure of angle, or the length of X. Okay, so now let me get this all out of the way. And now we're focusing on the other triangle. So let me go back to my highlighter. And now we are going to, oops, let's make it a little thinner. Holy cow. Let's see, here's the triangle we are talking about. Oops, forgot that does line segments. Let me do that, stop, let me do this, stop, and let me do that. Okay, so this is the triangle that we are focusing on now. Notice there's 2 arcs here, 2 arcs here. That means the measure of angle N equals the measure of angle M. Since those 2 angles are congruent, then the opposite sides are congruent by the, let me go back and show you. It's the base angle theorem. If the two base angles, and this is all messy now, if the two base angles are congruent, okay, then it's this one here, it's the converse. If the two base angles are congruent, then the sides opposite are congruent. So let me go back to that problem. All right, so since this is congruent to this, the sides opposite are congruent. So NL, so now I can say NL equals ML. And ML is x plus 1. But this is an equiangular triangle, and we now found that y equals 4, and so this side here is 4. Equilateral triangles are equiangular. So if y equals 4, then this opposite side here also is 4. So 4, 4, 4. Now I know NL is 4, and there is my equation. 4 equals x plus 1. Now I just need to subtract 1 from both sides, and I find x. So x is 3 and y is 4. We found x and y. All right, so that's how you have to take problems apart, looking at diagrams and seeing what you're given. Sometimes it's muddled, but you have to sift through and find the facts. So now you should be able to find do numbers 13 and 14 on the problem set. Okay, so now let's take a look at example 4, solving a multi-step problem in a real world situation. So in this lifeguard tower, side PS is congruent to QR. So I'm going to mark those congruent. Actually, let me move the diagram off and then we'll discuss it there. Okay, so I've made a copy. So I'm going to just move this over like so. So here is our diagram without all the background to muddle our view. So let's take a look at this. Okay, my pen's malfunctioning. One moment. Okay, so here we go. PS. Well, here is P. Here is Q. R is down here. S is here. They labeled this angle 4. This one is 3. This one is 1. And this one is 2. All right, so we were given PS is congruent to QR. So that's congruent to that. Angle QPS. QPS is this whole thing here. Is congruent to angle PQR, which is right here. Okay, so now we have a different overlay of two triangles. Okay, so now what you need to do is be able to take this triangle, and I've broken it up again. So these angles overlap. So what I'm going to do is move this triangle off the other. So how about I do it this way? So now, as you can see, they were together. So P and Q coincide, and I move them off, and they're actually two different angles now. So we were told the measure of angle QPS is congruent to PQR. All right, so now we can see what they're talking about when we explode the diagram. Okay, so part A says to explain how to prove that QPS is congruent to triangle PQR. All right, and the first thing you need to do is draw it so they don't overlap, which I've done. And now let's take a look at this. We know PS is congruent to QR. So now I'm going to work over here. PS is congruent to QR. So now I have an angle congruent to an angle and a side congruent to a side. But what we have to identify is PQ right here is in both triangles. It is shared. So we know that PQ is congruent to itself by the reflexive property. Okay, and that's why it's isosceles. And now that I have a side and an angle and a side, so the angle's included, I can prove that QPS is congruent to QPR by side, angle, side. And PQT is isosceles. Triangle PQT. Where's T? Ah, I missed that. Here's a T right here. All right, so explain how to prove why these are congruent. PQ is congruent to itself by the reflexive property, and I'd write that, okay? PQ is congruent to PQ reflexive. And then we have a side angle, and then SAS proves the triangles are congruent. Two sides and an included angle are congruent to two sides and an included angle. Now part B says explain why triangle PQT is isosceles. So P is here, Q is here, T is here. So now what they're talking about is the little triangle inside that overlap right here. And let me draw that. Okay, so now what I'm going to do is I'm going to move this triangle, and there's PQT, okay? Kind of buried in there. So here's PQT. Okay, so it says we want to prove or explain why this triangle is isosceles. All right. So what we're going to do is, this one's a little trickier. So where did PT come from? PT was a segment that came across here and continued to R. PT is here, TR is here. So I could say PT plus TR equals PR. Okay, so PT is here, TR is here, and that makes up the entire PR. PT is here. All right, and then going the other side, I can say, let me do it in green. I can say QT, which is from here to here, plus TS, plus segment TS is equal to QS. All right, QT plus TS equals QS. Well, over here, these two triangles are congruent because of side angle side theorem. So that means QS is congruent to PR. Okay. So here's PR. I forgot my line over top. Here's PR. And here's QS. So these two are congruent. So then I can say, well, that means PT plus TR equals QT plus TS. Okay? Because PR is equal to QS, I can set these two equal by the transitive property. Okay. Now, this is the hard part. How do we prove the pieces are congruent? Okay, so what I'm going to do is I'm going to move this triangle here. And that way I can identify where T would end up, which is right there. And then I'm going to move it over to here because it came from the same diagram. And now I know that T is right there. All right, so let me move this back. Let's put it right here, actually. So now I know this is T and this is T. All right, so from part A, I know angle 1, which is P, is congruent to angle 2, which is Q. Actually, no, it's not. It's the small one inside. So we were given from the beginning, angle 1 is congruent to angle 2. Okay, so that means that this angle is congruent to this angle here. Therefore, PT is congruent to QT. Okay, and then if I knew that, then I can say TR is congruent to TS because of how they're related. Okay, so that is just the base angle theorem, because we can't forget what they said earlier, which I did for a moment actually. Angle 1 is congruent to angle 2 because it's a base angle, or because these triangles are congruent. And so the parts are congruent. So how does the book actually explain this? How does it word it? From part A, you know that angle 1 is congruent to angle 2 because PQS is congruent to, oh, it's right there. PQS is congruent to PQR. All right. So by converse of the base angle theorem, PT has to equal QT. All right, so let's just leave it at that, but we do have to break this up and conclude that the angles and sides are congruent in all these pieces. Corresponding parts of congruent triangles are congruent. Okay, that brings us to the end of chapter 5.4. It's kind of a short chapter, so I assigned some review problems at the end, 42 through 44. So please do these problems, and thanks for watching and have a great day.